kindergarten friends, you may have watched a video earlier about me using a balance. So I have a book called Using Scales and Balances. I'm not going to read the whole thing because it is kind of long, but we will talk a little bit about scales and balances and density. If you've ever played on a teeter-totter, you know how a balance works. Suppose two friends sit on either end of a teeter-totter at equal distances from the center. When they lift up their legs, the side the heavier person is sitting on goes down. If both friends weigh the same, the teeter-totter remains balanced. Balances are tools for comparing how much things weigh. A scale is another tool used to weigh things. It might surprise you how often people weigh things. Doctors weigh their patients. People weigh foods they buy in stores. Weighing things is a part of many science experiments. Sound familiar? Like the thing we did today? Everything, including you, is made up of matter. Matter is made of tiny parts called atoms. Mass is a measure of how much matter something has. So mass is something different than what they're going to talk about weight. Mass is how much matter is in something, whereas weight can change depending on the pull of gravity. Weight depends on gravity. Gravity is a force or pull between objects with mass. Weight is a measure of that pull. The more mass something has, the stronger its pull. Because Earth is so huge, its gravity is strong enough to keep people and other things from floating off into space. You weigh more on Earth than you would on the moon because Earth has more mass. However, your mass remains the same no matter where you are. So with first grade, we read a book about gravity and the moon, and it talked about if a cow on Earth weighed 600 pounds, and then you took that cow to the moon, the cow doesn't change size. It's going to be the same cow, but on the moon, it only weighs 100 pounds because there's much less gravity or pull on that cow, and therefore, or on that mass, and therefore it weighs less, but it's still the same cow. So the United States, generally, we use the customary system. We measure things in ounces and pounds. A pound equals 16 ounces. For objects with more mass, like elephants, we use tons. There are 2,000 pounds in a ton. Other countries use the metric system. Scientists use it too. It measures mass in grams and kilograms. So this bathroom scale weighs things with pounds and in kilograms. And this kitchen scale does the same. How to use a balance. Balances work by comparing the mass of two or more objects. They have three main parts, much like a teeter-totter. A beam, or long arm, balances on a fulcrum. They're in the center. So on my balance, it was the arrows. That was the fulcrum in the middle. The fulcrum is a center point. A pan hangs from each side of the beam. To use a balance, put the object you want to weigh in one pan. So over here, well, they've got weights on both sides. Over here, she's got what she wants to weigh on one pan, and over here, she's putting little weights that she knows the weight of. Place standard weights or objects whose weight is already known in the other pan until the scale is balanced. We weren't trying to determine if the balloons filled with water and sand and air, how much they weighed. We were just trying to figure out which one was the most dense and therefore which one weighed the most. Understanding density. You cannot always tell how much something weighs by looking at it. Fill one cup with water and another cup the same size with cooking oil. The water and the oil both have the same volume, which means they take up the same amount of space, like our balloons. The half cup of sand, the half cup of water, and then air all took up the same amount of space. If you weigh the 2 cups on a scale or balance, though, you will find that the cup with water weighs more, so it is more dense than the oil. Also, if you were to pour water and oil together, they would be separated, and the water would be on the bottom and the oil would float to the top because the water is more dense than the oil. While mass is how much matter something has, density is how tightly packed together that matter is. Water takes up the same amount of space as oil, but it has more matter. Denser objects weigh more than less dense objects of the same size. So these balls are the same size. The red balls on the right have a smaller volume than the yellow balls on the left. That means there's not as many of them. But they weigh the same. This means the red balls must be more dense than the yellow ones. So it says your turn. So if you happen to have a scale at home, you could try this out. It says, using a balance or scale, compare the densities of different foods found in your kitchen. You will need one balance or small scale, 5 small cups, all of the same size and height, 5 foods from your kitchen, such as milk, flour, salt, vegetable oil, and raisins. Fill each cup with 1 food. In a notebook, list each food. Without lifting the cups, make guesses about the food's weights. Which one will weigh the most? Which one will be the lightest? Write your guess beside each food. Using a balance or a scale, compare the food's weights. Did you guess correctly? Was something heavier or lighter than you thought it would be? Why do you think that was? This is something you can just talk about with your parents because I'm not expecting you to turn any of that in, but it's definitely something that is interesting that you could try out if you happen to have a kitchen scale or balance. If you don't, you could use a bathroom scale or balance and maybe compare yourself to a sibling. Now, they might have different mass. For example, my mass is greater than your mass because I'm bigger than you, so I would weigh more than you. But if your sibling had the same amount of mass, like you guys are the same size, you could compare weights and figure out which person was more dense than the other. And that's all I have. So see you later.